Ever wondered how a periscope works? Well, we are about to unravel that mystery for you. A periscope is a fascinating contraption, a device that allows us to see around corners and over obstacles. A tool of intrigue and wonder, its roots take us back to the early 20th century. A time when the world was at war and the need for stealth and observation was paramount. This simple yet ingenious invention was a game-changer in the military world, allowing soldiers to peek above the trenches without risking their lives. But it's not all about warfare and submarines. Periscopes have found their way into the innocent hands of curious children, becoming a staple of basic science experiments. They've even earned their place in the realm of entertainment, playing a crucial role in old-school film projection. Now that we know what a periscope is, let's dive into how it works. The working principle of a periscope is quite fascinating. It all comes down to light and reflection. Now, if you've ever bounced a basketball, you know that the angle at which you throw the ball determines where it goes. Light behaves in a similar way, but instead of bouncing on the floor, it bounces off mirrors or prisms. In a periscope, mirrors or prisms are the key players. These are placed at 45-degree angles. Wondering why this specific angle? Well, it's all about the path of the light. When light hits a mirror at a 45-degree angle, it gets reflected at an equal but opposite angle. This is what we call the law of reflection. Now, let's imagine a beam of light from an object you want to see. This light beam travels down to the first mirror in the periscope. Here, the magic of reflection occurs. The light is reflected at a 45-degree angle, sending it along the length of the periscope to the second mirror. The second mirror, also angled at 45 degrees, receives this light and reflects it once again. This time, the light is directed towards your eyes, and voila! You're now seeing the object, even though it might be on the other side of a wall or above a crowd. So, in a nutshell, the periscope works by extending your line of sight, allowing you to see over, around, or through objects. This is why they're so useful in submarines, where they allow the crew to see above the water while staying submerged. But it's not just submarines. Periscopes have a myriad of applications. They're used in tanks, for birdwatching, in construction, and even in some toy sets. All these uses are made possible by the simple yet ingenious principle of light reflection. In essence, the periscope is a simple yet ingenious application of light reflection. It's a beautiful example of how understanding and applying basic principles of physics can lead to incredible inventions that enhance our ability to explore and interact with the world around us. Understanding the working principle is one thing, but seeing how a periscope is used in real-life scenarios is another. Now let's dive into the fascinating world of periscopes in action. One of the most well-known uses of periscopes is in submarines. Submarines are designed to operate underwater, and the periscope is a vital tool that allows the crew to see what's happening on the surface. The periscope extends above the surface of the water, and through the magic of light reflection, images from above are transmitted down into the submarine. This enables the crew to navigate safely and spot potential threats or targets. Moving on to another robust piece of machinery, the military tank. Here, periscopes are used to provide a 360-degree view of the battlefield without exposing the crew to enemy fire. A series of periscopes around the tank allow the crew inside to see in all directions, providing a substantial tactical advantage. But it's not just the military that benefits from the periscope's unique abilities. In the construction and surveying industry, periscopes are used to view areas that are difficult to see directly. They can be used to inspect the underside of a bridge, for example, or to survey land that is blocked by obstacles. And let's not forget about science. Periscopes are often used in educational settings to demonstrate the properties of light. Through hands-on experiments, students can observe how light reflects off mirrors and travels through different mediums, using a periscope as an example. This practical application of scientific principles helps to solidify understanding and spark curiosity. In all these scenarios, the periscope proves to be an invaluable tool. It enhances our vision, allows us to explore unseen areas, and even aids in our understanding of science. From the depths of the ocean to the battlefield, from construction sites to classrooms, the periscope is truly a marvel of simple yet effective engineering. As we can see, the humble periscope has a wide range of applications, all thanks to the simple principle of light reflection. Now, as with any device, a periscope needs some care and maintenance to keep it functioning optimally. Let's start with the mirrors or prisms, which are the heart and soul of a periscope. These need to be kept clean and dust-free to ensure clear and bright images. It's best to use a soft, lint-free cloth to wipe them gently. Remember, abrasive materials can scratch the surface and degrade the quality of the image. Next, let's talk about alignment. This is crucial in a periscope because the path of light needs to be accurately directed from one mirror to the other. If you notice any misalignment, it's best to take your periscope to a professional. It may seem tempting to try to fix it yourself, but improper handling can cause more harm than good. Moving on to damaged parts. If you notice any part of your periscope is broken or not functioning as it should, you should consider replacing it. This might include the mirrors or prisms, the casing, or the eyepiece. Again, it's often best to seek professional advice if you're unsure. And remember, a periscope is a precision instrument. It needs to be handled with care. Avoid dropping it or knocking it against hard surfaces.